Hello and welcome to another episode of Lutra TV. Today we're going to be speaking about advanced process modules. My name's Quentin Griffiths, Chief Executive here at Lutra, and I'm joined by Ortenzio, our Chief Engineer. So to start things off, Lewis, can you tell us a little bit about what an advanced process module actually is?
So an advanced process module in ID is we basically look around a process, or we will look at a plant, and we take a lot of the data that's collected by council or that's available through a SCADA system, and we take a deep dive on some of the process parameters and some of the performance of that, whether it's a treatment process or it's a plant itself, to get to be able to quantify treatment outcomes and get some kind of analytical results around that, more so than just looking at a SCADA system output, such as the performance data, by using our process expertise and our understanding of the way that the plant works.
Yeah, right. So essentially, if I break that down a little bit further, we're talking about water and wastewater treatment plants. And so essentially we're going into these and we're taking all that process data that already exists within a plant, and then we're looking at how we maybe overlay different data sets to try and get an outcome. In terms of that, what type of outcomes are we talking about? Can you maybe give an example from, let's say, a wastewater plant?
Yeah, so for a wastewater plant, we can look at basically a biofilm system. So if it's a trickling filter, or it's an MBBR, or it's an MABR, or RBC, any of these biofilm systems. If you consider nitrification, we can look at the ammonia loading onto the system. And if you're just looking at data, you can say, well, that's you have a flow in milligrams per liter, and out is flow in milligrams per liter. And that tells you a certain picture, but we can then look and calculate what the kgs per day into the system and the kgs per day going out is. And then we can basically say that a layer deeper is, well, how much surface area do you have of media? So then that's the grams per square meter per day loaded onto the system, so a surface area loading rate, and then what is actually being removed, so the grams per square meter per day that's being removed, which is a surface area removal rate. And we can do a DO concentration, so we can estimate where we're sitting and meeting, where we're performing based on just empirical data that we have around how these systems should be performing, and basically identify whether the system is being overloaded, whether it's actually underloaded and it's not performing for various reasons. And if you take that as a paradigm, basically like the way that we would approach this, you can do the same for an MBR when it comes to flux. You can do an MBR plant, the entire plant, for chemical cost. So if we're having to meet a total nitrogen of 3 or 4, and you're spending X thousands of dollars a day on chemical, and suddenly you're spending 2X $1,000 per day on chemical, then that would suggest that there's a problem that's gone away. We can track this over the course of days, weeks, months. You can see seasonal fluctuations. That's the type of analytical view that we're taking on this. So some of it's short term, some of it's long term, some of it's things that you would take you would look at it from I need to change this valve, or maybe next year I should consider doing this for that season. So yeah, pretty powerful stuff.
Yeah, right. So I guess it's just trying to get that deeper insight as to how the plant's working, operating, and then I guess it's also trying to highlight where some of those issues might be lying, or how you might be able to tweak the plant further to get better performance. And I guess with that performance, that's not only just purely as a cost saving, that could be an improved removal rate, as you mentioned, with nitrogen and the likes. So particularly if you're tight on a consent condition or something like that, it just might highlight how you might be able to squeeze a bit of extra performance out with, I guess, what sometimes might be some minimal investment.
Yeah, that's right. It could be. It can be an optimization. So can you defer? It might give you insight into whether you can defer an upgrade for 3 to 5 years, or if it's something that you can, or it's basically how do you run your plant that's 2 years old, better for another 20 years, basically.
Yes.
So in some cases it's an optimization. Some cases it's a considered thing that you'll take a look at for a while, and then in other cases it's basically. Rather than a 0 or a 1, you have a 1, which is saying something's not working well at your plant at all, which is more like that chemical cost totalizer that I was saying. If you're spending double the amount of chemical 1 month than the previous month, there's probably something going wrong, and it might be your plant, or it might be something that's being discharged into your plant. which is something that you might have to look into.
Yeah, right. So I guess again, it's just that extra visibility around the plant. So outside of purely just a SCADA data platform or something like that, where you're just seeing that process values coming through, you're overlaying a little bit more knowledge and expertise in there to actually try and get an outcome, which I think is what makes these somewhat special. It's a combination, I guess, of that pure data processing kind of aspect and that data analyst type view, and then I think it's merging in some of that engineering knowledge that is unique to Lutra and actually forming up something which can give you a different sort of outcome. I guess an example that I know about from the water side of the business as well is looking at, again, speaking of filters, and just looking at their overall performance. So where you're actually plotting out maybe a range of different filter banks. So if you have more than one filter bank operating, you can actually start comparing one against the other. You can look at those head loss ratios, you can look at those efficiencies. So again, where you're in a potentially water constrained environment, if we're thinking drought seasons or anything like that, you might be able to squeeze another couple of percentage efficiency out of these filters. So in reviewing your backwash process, things like that, where you might be over backwashing, under backwashing, and again, you might be seeing a lot of water wastage there. So I think, again, it's just taking that SCADA data, taking potential laboratory data, and then combining that up to give you some kind of outcome. I guess with this, is this something that you can just roll out in accounts, or is it something that you can just turn up and connect, or is there some process or maybe data collection changes that might be needed?
Well, in general, it's not something that we can just turn on. It requires some knowledge around the plant. In most cases, with people that we work with, we do know a fair amount about the plant, filter sizes, activated sludge tank sizes, MBBR sizes, trickling filter sizes, things like that. So we do have to take a bit of time for a setup to set the advanced process module up and set the calculations up, whether it's soft sensors, how we want to set the batch report up, dashboards, the timing. So some of these calculations, we would look at averages over the course of a week, because it's not really something that's a day-to-day thing. Like a SRT or an F to M might be a weekly calculation where we take 3 results and we average it across a week. And in some cases, the data that's being collected, while a lot of data is collected and there's typically usefulness in all of it, it might just not be as representative or quite as useful as we would like. So we may request that additional data gets collected, or data be collected in a different way or a different time interval, something like that. So there's typically a bit of a discourse back and forth between the engineering team, client, and the ID to try and really reach this best outcome. Else, we're trying to make calculations or analytical decisions on data that's just not collected the best way. And it doesn't have to be collected the best way. We can create some outcomes from that, but to really get the best analytical value out of this, we want to try and optimize the data collection and frequencies as best we can.
I guess kind of thinking down that, I mean, with SCADA, generally that's an easier change to make. You might just increase the frequency of data points coming in, things like that. If there is investment required where, I guess, a client's looking to install additional meters or anything like that, we could, I guess, give advice on where those need to be placed. But I guess in that more laboratory realm, I guess that's the part which we often see data probably lacking in. So is there something that needs to be done, thinking wastewater and laboratory sampling, is there better ways that we can be doing that to actually help not only influence this, but even further down the track, design characteristics, things like that?
Yeah, I guess to go with design characteristics, so like influent characterization of wastewater plants, that's something that's typically very reactive, and it's typically done whenever when we get asked by a client, we have a resource consent that's coming up. We'll need to get a new one, and it'll be more stringent, and we probably need a new wastewater plant. The first thing that we say is, okay, well, what sampling data do you have for the raw influent? And they say, well, we have 3. And we say, no, we need more than that, right? So which is one of the reasons why we released a sampling schedule, and that's on our website to be able to see. But the idea is, if you collect this data proactively, we can set up what is basically a raw influent characterization module for your plant, and we can look at flow rates coming into the plant. So we can do average dry weather flow, peak instantaneous flow, estimate infiltration and inflow based on some of those parameters. We can look at the population In the wastewater catchment, we can calculate the kgs per day. We can relate that to grams per capita per day. We can detect things like septage dumping or trade waste that's not monitored, because the grams per capita per day could be much higher than the national average. All of these things are the types of things that we can look at. It takes a proactive approach to collecting this data. As part of this, it's one of the reasons why we're giving away some of that IP, because we think that there's value in trying to get to that next step of, well, here's what you have to collect it, and then we can analyze it, and we can continue to analyze it through these advanced process modules. So take that raw influent characterization example and apply it to anything. If you want to know more about your disc filters, DAFs, or drinking water, your membrane plant or your clarifier, sample here, sample there, do it this many times a week at this time, match it up with this online data, give me that totalizer, and we can calculate a lot around how these plants are performing, how they're running, how are they supposed to run, what do you need to consider in the future. When do you hit a pinch point? So when do you reach the capacity? Is that 2035? Is that 2040? Did it happen 5 years ago and you just didn't know it, and you've been fighting that battle ever since? Like those types of things. The more we talk about this, right, I tend to have more performance angle and an operational angle. How does a plant perform? How do you operate it? Those types of things. How would you operate it better? How would you optimize it? But when we talk about raw influent characterization, I think about modeling. But what's also really quite valuable, and we kind of talk about that when it comes to a capacity and when you reach capacity, is planning and asset management. So while these advanced process modules make a lot of sense when it comes to, in my mind, and I'm thinking about them from a very specific angle, but they're useful to a lot of different people. It's useful to planners, it's useful to asset managers, it's useful to people who have to manage catchments, people who are doing reporting, and then there's the bits where it's useful to people who are process engineers for council, or operations managers or operators, and they're versatile.
So I guess, looking at these advanced process modules, right? Primarily what we've been talking about is just managing data, working with data, and then trying to get some outcomes from data. So there's a lot of data collection platforms out there. I guess, how is this different from what they can do?
Effectively, what we're doing is we're embedding our consulting engineering into ID. So we're taking our process expertise and we're finding a way to embed that into ID. And that's the bit around the setup, is that if we could do it automatically, we would have done it already. And in some cases, we have done this already. And we do it every time we do a report for somebody in the consulting space. Because in that situation, we get to engage with the client, and we get to say, we need you to collect data here. Can you provide us that data? Can we look at this? And it's just about formalizing that and making that a regular occurrence, where data is collected at regular intervals, and then we are expecting that data, and then we can analyze that data. But effectively, we're taking this engineering, which we do for all of our clients in the consulting space, and anything that we quantify in that engineering space, whether it's an operational parameter or it's a capacity or any of that stuff, we can embed into ID. And that's basically what an advanced process module is. It's just embedding our consulting work into ID, and it just takes a little bit of time to do that, but it yields powerful outcomes, basically.
So I guess it's in summary, it's essentially taking that knowledge that we've learned over years and years, and that operational expertise that we have through our team, and taking that, overlaying that data on top, and then basically building that IP in there. So we can actually drive a better outcome there. And I guess to a degree as well, it's making this so it's accessible for a lot more of the different municipals out there, particularly some of the smaller municipals. And it also just helps, I guess, improve their overall operations. So that's where we've done some of that sample planning, and we've actually released that open source, just so that where some of these councils would like to make a change, they'd like to improve the way they do things, it's not that they have to pay for it every time. So by open sourcing that, we can hopefully lift the whole industry up as we go. So look, thank you for your time today. Really appreciate learning a little bit more about these advanced process modules. What I'd say is, if you want to learn more about this, please reach out to Lutra. We're always happy to have a discussion and give you a little bit more detail on what one of these would take to roll out. And don't forget to like, subscribe, and follow our YouTube channel for more.